This is my class on quadratic equations. I have a quote here by a famous writer who says that they cannot do quadratic equations despite how much they like science. If you don't know, quadratic equations feature a lot in science and physics especially, and and we all like science, but sometimes the math can scare us away. Hopefully, at the end of this class, we'll feel a lot better about the math and quadratic equations especially. So we're going to focus on a technique for solving quadratic equations called completing the square. So what does it mean to complete the square? Well, it's like you have a jigsaw puzzle, and I'll explain where these green and blue pieces and yellow pieces arise from. But basically, when you move this yellow piece into the green and blue piece, you get a square. And so that is your square, your completed square. So if I was going to ask you, how can you describe the square just with numbers, what would you say? Describe the square to me, but use only numbers. Well, some people might describe a property of the square like its area. So we know the area will be 4. So 4 describes the square. But you know, in math, letters can stand in for numbers. These are variables. So if we take the area of the blue piece and the area of the green piece and the area of the yellow piece, and we add them up, you will get the area of the entire square, right? And if we make x equal to 1, then this square can also be described as x squared plus 2x. And if it's x squared plus 2x, if that's the area, if that describes the area, then we can make an equation that says 4 equals x squared plus 2x. And now we gotta combine like terms here, right? We wrote x squared twice. It would be easier just to write 2x squared plus 2x equals 4. And this is basically a quadratic equation. We bring the 4 to the other side, and now we have the standard form for a quadratic equation, where it's equal to 0 at the end. And you can see there are pieces from the square earlier. So you see the quadratic equation and a shape are very closely related. So here's a challenge. Let's suppose you have an equation x squared plus 5x equals c. What would c be such that the quadratic equation has like solutions that are real numbers? So how can we solve this challenge? Well, I mean, we could guess a bunch of things, but we could also be like logical. And actually, we have a hint from Einstein that appeared out of nowhere. It says use the square. So let's try using the square method. Okay, so this is x squared, 1 by 1, and then this is 1 by 5, right? Because it's like 5 x's, so you can imagine they're like five green squares would fit into this blue rectangle. And now we just gotta fill in the blank with like a yellow piece, right? And then count out the dimensions of the yellow piece, and we're done, right? So is this what we have to do? Is this going to work? No, because it's not a square. It has to be a square. So what do we do, right? How do we complete the square now? Well, we have to cut the blue piece in half, and then we'll be able to make a square. So now we cut the blue piece in half. It was 5 by 1, so now it's 2.5 by 1. We put it on either side, and that means that the yellow square that will complete this larger square will have an area of 2.5 by 2.5. 2.5 squared is 6.25. So let's add up all the areas of our completed square, and that will be 12.25. So now let's create an equation out of that, just like how we did before. Combine like terms. We solve for c, and c equals 6. And we're done.